Hello and welcome to Easy Sleep Science. I'm so glad you're here with me tonight. Our journey this evening will take us to the quiet companions of the universe, the moons. These silent wanderers drift around planets large and small, shaping tides, stirring atmospheres, and keeping ancient secrets beneath their frozen surfaces. Some moons are scarred and ancient silent witnesses to billions of years of cosmic history. Others are alive with volcanoes, geysers, and shifting ice. Earth's moon is just the beginning. Farther out lies Titan with its seas of liquid methane, Europa hiding a vast ocean beneath its crust, and Enceladus spraying shimmering plumes of water into space. Some moons are shaped like potatoes, some like sponges, and some even glow beneath their own auroras. A few may hold the chemistry of life itself. To understand the moons is to touch the secret stories of our solar system. If you enjoy these gentle journeys, please like, subscribe, or share your thoughts below. That small act helps other souls seeking peace find their way here, one person, one dream at a time. Now you don't need to do anything at all. Just let go. Let your breath slow down. And let the quiet rhythm of the moons carry you away. If you're ready, let's begin. Earth's moon is slowly drifting away. Each year it moves about 4 centimeters farther from our planet. This happens because Earth's rotation stirs the oceans into tides, transferring energy to the moon and pushing it outward. That means long ago the moon was closer, brighter, larger in the sky, and its pull was stronger. In the far future, Earth's days will lengthen as its rotation gradually slows. The change is slow beyond imagination, yet it reminds us that even something as seemingly eternal as the moon's orbit is quietly evolving with time. The sky we see tonight is not the same sky our ancestors saw, and it will not be the same sky our descendants will see. Once the moon had its own atmosphere. Billions of years ago, it was not the airless world we know today. Volcanoes erupted across its surface, releasing gases that formed a thin atmosphere lasting tens of millions of years. Eventually, those gases escaped into space, leaving behind a silent world. Scientists believe that ancient air may have helped water find and remain in shadowed craters where ice still lingers today. When we look at the moon, it feels timeless. But its past tells another story, a time when it breathed, then fell silent again. Not all moons are round. Some are shaped like potatoes or flying saucers. Phobos Mars' moon is a lumpy potato. Pan, one of Saturn's tiny moons, looks like a ravioli with a ridge around its equator made from ring material it has swept up. These odd shapes exist because small moons lack the gravity to pull themselves into spheres. Instead, they remain misshapen, rugged relics, cosmic toys left over from the solar system's construction. While the giant moons resemble full worlds, the smaller ones are fragments, fossils of the universe's dawn. Europa hides an ocean that may contain twice as much water as Earth. Beneath its cracked, icy crust lies a global sea kept liquid by Jupiter's immense gravitational squeeze. The surface bears ridges and fractures, traces of ice plates drifting over the hidden sea. Some scientists believe its seafloor may host hydrothermal vents, where minerals and heat mingle, potential cradles for primitive life. Europa may be cold on the outside, but deep below it, could be one of the most promising places to find life beyond Earth. Titan, Saturn's largest moon, has rivers and seas of liquid methane. It's the only world besides Earth with stable surface liquids. But instead of water, it's rain, and lakes are made of methane and ethane. Clouds drift, rain falls, and landscapes form in a chemistry utterly alien. Imagine standing on Titan under a hazy orange sky, dense air pressing around you, horizons reflecting the glimmer of methane seas. A world both familiar and foreign, where rain is made of frozen gas. Enceladus breathes water into space. Beneath its thick shell of ice lies a salty ocean. From cracks near its south pole, plumes of vapor shoot hundreds of miles high, sparkling in sunlight. The Cassini spacecraft once flew through them and found traces of organic molecules. A tiny frozen world, but alive, exhaling glittering breaths into the void. Io, Jupiter's fiery moon. Nowhere in the solar system is it more volcanically active. Hundreds of volcanoes constantly reshape their surface lava, covering lava in endless renewal. A world of fire orbiting in darkness. Ganymede, the largest moon, has its own magnetic field, the only moon that does. Even Mercury doesn't. Inside lies a molten core of metal. Above it, a crust of ice and oxygen carved by mysterious grooves. If it orbited the sun, we might call it a planet. Without the moon, life on Earth might never have begun. It stabilizes our planet's tilt, moderates seasons, and drives tides that may have cradled life's first spark. The moon isn't just our companion, it's our quiet guardian. The moon was born from a colossal collision. About 4.5 billion years ago, a Mars-sized body struck the young Earth, flinging molten debris into space, and from that, the moon formed. A scar of creation turned into our most loyal friend. The moon's far side, the one we never see, is rugged and cratered. Unlike the near side, it's mountainous and rough. Only in the 20th century did humanity finally see it through spacecraft images. Triton, Neptune's largest moon, orbits backward, proof that it was captured, perhaps a wandering dwarf planet. One day it will be torn apart, forming a new ring around Neptune. Phobos, Mars' moon, is slowly falling inward. It moves 2 meters closer every century. 50 million years from now, it may shatter into a dusty ring around the red planet. Miranda, moon of Uranus, looks pieced together from fragments. Its surface is scarred by cliffs, canyons, and the tallest known precipice in the solar system, Verona Rupes, 12 kilometers high. A world once broken and reborn. Though silent, our moon still trembles with moonquakes. Some are caused by Earth's pull, others by temperature changes, and some remain a mystery. Because its crust is dry and rigid, vibrations echo for minutes like a bell. Tiny glass beads on the moon hold water within them. Formed from ancient lava, these beads may one day provide water for future missions. They whisper of a fiery past and a hopeful future. Moon dust smells like burnt gunpowder. When Apollo astronauts returned to their module, the gray dust clinging to their suits gave off that strange scent. Sharp-edged and clingy, it could tear fabric, even harm lungs. A reminder of a world with no wind, no rain, no life, yet unforgettable. Some Apollo experiments still work today. Retroreflector mirrors continue to measure the moon's distance with precision, confirming its slow drift away. Beams of light link Earth and Moon like a silver thread across the night. Callisto, Jupiter's second largest moon, seems frozen, but beneath its ice may lie an ancient ocean that has endured for billions of years. A quiet world nearly unchanged, holding secrets of survival in the farthest cold. Iapetus Saturn's yin-yang moon shows one bright hemisphere and one dark. Dust from another moon, Phoebe likely coats its darker side, deepening the contrast when sunlight warms it. A strange ridge around its equator gives it the shape of a walnut, half shining, half shadowed, a cosmic symbol of balance. Hyperion tumbles through space like a spinning sponge. Small, porous, and chaotic, it never rotates the same way twice. Its low density suggests it's a loose pile of icy rubble, barely held together by gravity, fragile, yet mesmerizing. A cosmic sponge forever tumbling through Saturn's orbit. Some moons glow with their own auroras. Auroras aren't just for planets. Moons bathed in magnetic fields can shimmer with veils of light. Ganymede's magnetic poles blaze with aurora. Others glow faintly as charged particles sweep across them. We can't see these with our eyes, but spacecraft instruments can. Imagine a silent moon crowned in invisible light, a reminder that space hums with unseen energy, painting even the smallest worlds. Many moons hide oceans beneath their crusts, warmed by tidal forces. Far from the sun, these worlds should be frozen solid, yet gravity's pull flexes them, generating heat and keeping water liquid. Europa, Enceladus, Callisto, perhaps even Titan, each may harbor hidden seas. These secret oceans are among the most promising places to search for life beyond Earth. Beneath barren shells, entire worlds may stir, warmed only by the steady rhythm of gravity. Some moons have thicker atmospheres than Earth. It sounds impossible. Yet Titan's dense sky of nitrogen and organic haze presses heavier than ours. Its thick air shapes weather clouds, winds rain, sculpting alien shorelines. While our moon has only a trace of gas, Titan's skies resemble those of early Earth, giving us a glimpse into what our own world might once have been. A reminder that moons are not merely companions, but complex worlds of their own. Pan-Saturn's tiny moon looks like a cosmic ravioli. Barely 20 miles across, it's so oddly shaped it seems handmade. Its bulging equator formed as it swept up particles from Saturn's rings, carving a narrow gap in return. Pan may be small, but it sculpts the mighty rings around it, proof that even the tiniest moons can reshape their worlds. And Mimas, the Death Star. Moon stares back with a single giant crater, a cosmic echo of imagination meeting reality. Mimas, another moon of Saturn, is famous for its uncanny resemblance to the Death Star in Star Wars. The enormous Herschel impact crater dominates one hemisphere, giving it the same eerie look as that fictional battle station. But Mimas is anything but frightening. It's a frozen, battered world only about 250 mid across. The resemblance is purely coincidental, and yet it captivates anyone who's ever seen its image. However, scientists are intrigued by Mimas. For another reason, its interior may not be completely solid. Recent studies suggest it could hide a liquid ocean beneath its icy crust, turning a familiar moon into a far deeper mystery. Amala has valleys taller than Everest. Jupiter's moon. Amla is small and misshapen, but its landscape is extreme. Towering mountains and chasms carve up the surface, some rising higher than Earth's Mount Everest. Amla glows a faint red, possibly coated with sulfur from Io's eruptions. Though only about 100 meters long, it helps supply dust to Jupiter's faint gossamer ring. Its dramatic terrain shows that even the tiniest moons can carry majestic planet-like features, compressed into miniature worlds. Amtha may be small, but its peaks and valleys rival Earth's grandest landscapes. Himalaya is one of Jupiter's strangest captured moons. Far from Jupiter's main moons, Himalaya drifts as the largest member of a group of irregular satellites. It doesn't march neatly in line with the others, but follows an inclined, eccentric orbit. Scientists believe Himalaya is a captured asteroid, a wanderer pulled in by Jupiter's immense gravity. It's about 100 miles long, with a gray, ice-poor surface unlike the brighter inner moons. Himalaya is evidence that Jupiter gathers straws, turning them into moons and reshaping its satellite family. It shows that moons aren't always born where they currently orbit. Sometimes they're travelers captured and kept forever. Some moons orbit backward relative to their planets, while most moons move in the same direction as a planet's rotation, a few are rebels. These retrograde moons orbit the opposite way, defying the usual order. Triton Neptune's giant moon is the most famous example, but many smaller captured moons also follow backward paths. Their orbits show they didn't form with their host planet, but were snagged later out wandering through space. Capture can be violent sometimes, shattering other moons or tilting the whole system. A retrograde orbit isn't just odd, it's a clue to a chaotic history. A reminder that the solar system is full of chance encounters and dramatic abductions that reshaped worlds into the configurations we see today. Janus and Epimetheus swap orbits around Saturn. Two small moons of Saturn, Janus and Epimetheus, perform a delicate dance. They share nearly the same orbit, but instead of colliding, they trade places every few years. When the inner moon catches up to the outer one, their gravity exchanges energy, sending one sliding outward while the other falls inward. This orbital dance repeats endlessly, a graceful rhythm choreographed by gravity itself. The arrangement is rare, showing that moons can find stable patterns even in precarious positions. Watching Janus and Epimetheus is like seeing two dance partners change steps, circling Saturn forever, never colliding but always in harmony. Some moons spin so slowly they hardly seem to rotate at all. Many are tidally locked, always showing the same face to their planet. To us, it seems like they don't spin, though, technically. They rotate exactly once per orbit. But some irregular moons rotate so slowly that a single spin takes days or weeks, making them look almost stationary. This sluggish motion comes from their irregular shapes and the gradual breaking of gravitational tugs. Imagine standing on such a moon, the stars would crawl so slowly across the sky, you might need a week to notice the shift. These slow rotations remind us that time unfolds differently depending on where you stand in the solar system. The moon helps keep Earth's axis stable. Earth's axis tilts about 23.5 degrees, creating the seasons. Without the moon, that tilt could wobble wildly, swinging between extreme angles. Mars, lacking a large stabilizing moon, has undergone such swings, but Earth's moon, with its steady pull, damps those variations, keeping our climate relatively stable for billions of years. That stability may have been key for life to flourish, giving ecosystems time to adapt and evolve without sudden planetary upheavals. The moon's influence is quiet and persistent, invisible in daily life, yet it's a cosmic anchor holding Earth in balance amid the vastness of space. The moon lengthens Earth's day over time. Long ago, Earth spun much faster. A day may have lasted just 6 hours. But as the moon raised tides in the oceans, energy gradually shifted from Earth's spin to the moon's orbit. The result, Earth slowed down and days grew longer. Today, we gain about 1.7 milliseconds per century. The effect is tiny, but over billions of years, it adds up. The length of the day you experience isn't the same as it was for the first living things. Simply by circling Earth, the moon has stretched time, reshaping the rhythm of our world. Our moon once blazed with seas of lava. Look at the dark patches on the moon's face. Those vast plains are ancient lava flows that solidified. Billions of years ago, massive impacts cracked. The lunar crust and molten rock flooded the surface, spreading into bright, fiery seas. The Maria Latin for seas slowly cooled into the dark basalt plains we can still see with the naked eye. To early sky watchers, they looked like oceans inspiring countless myths. But their true story is even more dramatic. The moon once glowed with rivers of fire, its face remade by lava tides that hardened into the markings we see every night. Our moon holds water ice in eternal shadow. At both poles, some craters never see sunlight. Their floors remain in perpetual darkness, with temperatures plunging hundreds of degrees below zero. In these cold traps, water ice has accumulated for billions of years, delivered by comets and asteroids. The ice lies undisturbed in the dark, untouched since it arrived. For future explorers, these frozen stores could provide drinking water, oxygen to breathe, and even rocket fuel. The discovery of lunar ice has changed how we see the moon, not just a barren rock, but a world with hidden resources waiting quietly in the shadows. The moon reflects only 12% of sunlight. The moon looks bright in our night sky, but it's actually quite dark. Its surface reflects only about 12% of the sunlight that hits it, darker than old asphalt. The illusion of brightness comes from the contrast against the black of space. If you place the moon next to Earth in space, it would look dingy gray compared to our blue-white planet. This low reflectivity, called albedo, comes from the moon's basaltic soil dust. What appears to us as silvery brilliance is really the faint glow of a very dim world, yet bright enough to light our nights and spark our imagination. Lunar soil slices through spacesuit fabric like glass. Moon dust isn't soft like sand on Earth. It's made of sharp, tiny grains formed when micrometeoroids shattered rock into glassy fragments. With no wind or water to smooth them, the grains keep their jagged, abrasive edges. Apollo astronauts found that lunar soil stuck to everything, wore down seals, scratched visors, and even cut fabric. Inhaling it would be dangerous, as fine particles could lodge in the lungs. Walking on the moon is like stepping into a field of tiny, invisible knives, persistent and unforgiving. Dust is both the record of billions of years of impacts and a challenge for every future mission. The moon's gravity makes Earth slightly egg-shaped. The moon's pull doesn't just lift ocean tides, it also stretches Earth itself. Our planet bulges slightly toward the moon, giving Earth a faint egg shape. The effect is tiny, detectable only with precise instruments, but it reminds us how deeply the moon influences our world. Its gravity threads through rock, water, and air, tugging gently but relentlessly. Earth and the moon are locked in a gravitational embrace, affecting each other in ways we rarely notice, but that ripple through the whole Earth system. Moons can be torn apart by a planet's gravity. A moon that wanders too close to a planet can cross the Roche limit. Inside this distance, the planet pulls more strongly on the near side of the moon than the far side, stretching it apart. If tidal forces exceed the moon's own gravity, it can be ripped to pieces. Astronomers think Saturn's spectacular rings may have formed this way from a moon that ventured too near and was shredded. In the distant future, Mars's Phobos may meet that fate, gradually ground down. The idea that a solid world can unravel into countless fragments shows how even moons are fragile under the giant hand of their parent planet. Some moons are tidally locked in perfect rhythm. Many moons always show the same face to their planets, a state called tidal locking. Our moon is the classic example. It spins exactly once per trip around Earth, so we always see one side. Tidal locking happens as gravity gradually slows a moon's spin until it matches its orbital period. The result is a gravitational rhythm, like a balanced dance. Though it hides one hemisphere from its planet forever, the state also brings stability to the system. Locked moons show how gravity can mold time and motion into harmony. Sometimes moons trade orbits with each other. Not all orbits are fixed. Some pairs of moons can swap places in a subtle gravitational exchange. Saturn's Janus and Epimetheus are a famous example, sharing nearly the same path around the planet. Every few years, the inner moon catches the outer one, and instead of colliding, gravity makes them switch orbits. This cosmic position change has repeated for millions of years, like a perfectly balanced routine. It shows that even small moons can coordinate in astonishing ways, finding stability through motion. Watching them trade places is like seeing gravity write choreography across the sky. Earth's moon may help trigger earthquakes and nudge volcanoes. The moon's pull doesn't just raise the seas, it also flexes Earth's crust. Stress from these solid Earth tides can sometimes help tip faults or magma chambers that are already near a threshold, a phenomenon scientists call tidal stress. While it doesn't cause quakes on its own, it can give a timely nudge. It's astonishing to think the moon so far away can touch the tremors beneath our feet. Our planet and its satellite are linked not only by light and tides, but also by the subtle rumblings below. Ganymede's crust is layered like a cosmic sandwich. Beneath its icy surface, Ganymede may hold multiple stacked oceans. Ice, then liquid water, then ice again, and so on, a sandwich plunging miles deep. This strange structure may arise from enormous internal pressures that force water and ice into exotic phases. With a molten core generating a magnetic field, Ganymede is far more complex than a typical moon. It's like a miniature planet complete with oceans, magnetism, and varied geology. If we could slice it open, we'd see layer upon layer of ice and water, a frozen architecture found nowhere on Earth. Io's lava flows can run for hundreds of miles. Io is a world of heat, the most volcanically active place in the solar system, and its eruptions create rivers of lava stretching hundreds of miles. Those glowing red streams constantly remake the surface in a cycle of destruction and renewal. Some eruptions send plumes hundreds of miles high, visible from orbit. Unlike Earth's scattered volcanoes, Ios are everywhere, turning the entire moon into a restless volcanic landscape. From orbit, its surface flashes with fresh scars, a relentless reminder of tidal heating under Jupiter's hand. Europa's icy shell constantly renews itself. Europa is a vast ice sheet crazed with ridges, cracks, and streaks. Unlike most crater-pocked moons, Europa looks young, and active ice slides, breaks, then refreezes, erasing older marks. Beneath lies a global ocean. Heat from tidal forces keeps the ice in motion above. Some fractures may vent material from the ocean up to the surface, leaving reddish streaks where salts or organic compounds well up. The constantly renewed surface suggests a restless world where the frozen crust is just a thin skin over a living ocean. Callisto's ancient craters may be 4 billion years old. Callisto, the outermost large moon of Jupiter, is a relic from the deep past. Its surface, packed with impact craters, makes it a frozen record of the solar system's dawn. Some of the largest scars may be nearly 4 billion years old, preserved because Callisto has little to no geologic activity to erase them. Unlike Europa or Io Callisto, is quiet, almost tectonically inert. To look at Callisto is to peer across epochs into chapters of history that Earth has long since wiped away. Titan has mountain ranges taller than the Rockies. Though shrouded in haze, Titan's surface hosts ranges higher than Earth's Rockies. These peaks aren't rock, but solid water ice as hard as stone in Titan's cold. Tectonic forces, and perhaps even cryovolcanism, have lifted them up, carving rugged terrain. Enceladus's jets feed Saturn's rings. The icy moon, Enceladus, continuously sprays water vapor and ice crystals into space from fissures near its south pole. These plumes are powerful enough to replenish Saturn's E-ring, forming a tenuous halo of material around the planet. Every grain in that delicate ring may once have belonged to Enceladus's hidden ocean, hurled outward by tidal forces. The tie between a tiny moon and a giant ring system reveals the subtle interactions among orbiting worlds. Enceladus, only about 300 miles across, still leaves its mark on one of the solar system's most beautiful masterpieces. Triton's surface is made of nitrogen ice. Triton, Neptune's largest moon, is covered in nitrogen ice, giving it a pale, frozen surface. Unlike water ice, nitrogen ice is soft and mobile at Triton's super cold temperatures, letting landscapes shift and smooth over time. Voyager 2 recorded nitrogen geysers that left dark streaks across icy plains. These plumes prove Triton remains active, reshaping itself at the edge of the solar system. Its unusually smooth surface compared to other moons suggests it is continually renewed by this ice activity. Walking on Triton would be crossing a field of nitrogen ice where the familiar terms alien and even ice behaves strangely. Charon has a canyon system nearly 4 times deeper than the Grand Canyon. Pluto's largest moon, Charon, bears a colossal chasm that dwarfs anything on Earth, stretching over 1,000 miles and plunging to nearly 4 times the depth of the Grand Canyon. Scientists think it formed when Charon's icy interior expanded, cracking the crust wide open. The scale of this gash makes it one of the solar system's most spectacular fractures. Stand at its rim if you could, and you'd see cliffs dropping into shadow walls big enough to swallow Earth's grandest scenery. Charon is small compared to planets, but its terrain shows that small worlds can carry giant scars. Verona Rupes on Miranda is the tallest cliff in the solar system. Miranda, a small moon of Uranus, hosts Verona Rupes, a cliff estimated to soar up to 12-kilometer high. A fall from its edge could take 10 minutes to hit bottom. Scientists think Miranda was shattered by a major impact and then reassembled, leaving a jumbled surface and sky-high escarpments. Verona Rupes stands as a monument to that violent past, dizzying in scale unmatched anywhere we know. On a tiny moon, a cliff higher than Triple Everest is almost unimaginable, a geologic wonder on a scarred world. Neptune's moons were likely captured from elsewhere. Unlike Jupiter or Saturn, where moons grew from the gas and dust disk around the planet, Neptune's moon system seems collected from the outside. Many of its satellites have odd inclined or retrograde orbits, strong signs of capture. Triton itself is thought to have been a dwarf planet before Neptune's gravity hauled it in. Such captures must have been violent, likely disrupting or destroying earlier moons. The result is a system assembled from outer fragments, a collection of wanderers gathered into Neptune's orbit. To see them is to see fossils of ancient migrations, reminders of how dynamic and chaotic the solar system's past truly was. Phobos's grooves may mean it's falling apart. Phobos. Mars's larger moon is etched with long grooves and cracks running across its surface. For decades, scientists debated their cause. Were they carved by impacts or by boulders rolling across the surface? The leading idea now is even more dramatic. The grooves may be signs that Phobos is breaking up. Mars's gravity constantly tugs at this tiny moon, and over millions of years, those stresses may be tearing it from within. The grooves could be the first fractures in its slow self-destruction. If so, Phobos is a world with a doomed fate, already bearing the scars of its inevitable end. Deimos rises and sets so gently it barely seems to move. Mars's smaller moon, Deimos, is tiny, lumpy, and farther from the planet than Phobos. Its high, smooth orbit means that seen from Mars, Deimos looks like a faint star drifting lazily across the sky. Unlike Phobos, which races overhead and disappears quickly, Deimos rises and sets so slowly it hardly seems to move at all. Standing on Mars and watching Deimos is to feel a calm, gentle presence, nearly motionless against the backdrop of space. Its stillness contrasts with Phobos's drama, turning Mars's sky into a stage for two very different moons. Some moons are so dark that they barely reflect any light. Not every moon gleams with reflected sunlight. Some are black as coal, reflecting only a few % of the light that hits them. Himalaya, an irregular satellite of Jupiter, and many small outer moons of Saturn fall into this group. Their dark surfaces suggest they may be captured asteroids coated in carbon-rich material. These moons hide in the dark, invisible to the naked eye, even up close. Their inky blackness tells of origins in the cold, primordial outskirts of the solar system where sunlight rarely reaches. They belong to the faintest wanderers' worlds that whisper instead of sparkle. Other moons shine as bright as fresh snow. At the other end of the scale are moons that reflect nearly all the light that hits them. Enceladus, kept fresh by continuous plume deposits, gleams like pure snow. Its albedo is among the highest in the solar system. Seen from space, it shines like a pearl against the black. That brightness isn't just pretty, it tells us the surface is constantly renewed. While dark moons show their age with soot and scars, bright fresh moons like Enceladus reveal youth and activity. Their light is a signal of inner power endlessly resurfacing their faces. Some moons travel in clusters like tiny solar systems. Around the giant planets, moons don't always fly solo. Dozens of small, irregular moons form loose clusters orbiting together like miniature solar systems. Many share inclined or eccentric paths, hinting they are fragments of a larger body shattered long ago. Both Jupiter and Saturn host such families of moons, a collection of debris held by planetary gravity. Studying these clusters reveals past violent collisions that broke big worlds into swarms of small ones. Today, they drift in quiet company fragments forever bound to the giants they circle. The 4 Galilean moons of Jupiter changed science forever. When Galileo turned his telescope toward Jupiter in 1610, he saw 4 small stars moving near the planet. Night after night, they shifted positions, and he realized they were moons orbiting Jupiter. The discovery shook science to its core. It showed that not everything revolves around Earth, supporting the heliocentric solar system. Io, Europa, Ganymede, and Callisto became the first known worlds beyond Earth. They remain among the most compelling objects in the solar system, each unique, each revealing something new about planetary systems. That discovery was the first step toward seeing our place in a vast, complex universe. The discovery of the Galilean moons proved Earth is not at the center. In 1610, Galileo Galilei peered through a handmade telescope and noticed 4 bright points near Jupiter. Over several nights, he watched them circle the planet. They were Io, Europa, Ganymede, and Callisto, and their motion revealed a bold truth. Not everything in the heavens revolves around Earth. In an era when most believed in a geocentric cosmos, Galileo's finding was undeniable evidence that planets have their own satellites. It was a turning point, shaking old doctrines and paving the way for the modern view of the solar system. The sight of those tiny moons was more than a discovery. It was proof that Earth is not the center of all things. Some moons are locked in orbital resonances. Among the 4 Galilean moons, 3 are locked into a perfect gravitational pattern called a resonance. Io, Europa, and Ganymede orbit in a 1-2-4 rhythm. For every lap, Ganymede completes Europa, makes 2, and Io makes 4. This resonance helps sustain tidal heating inside Io, and Europa, fueling Io's volcanoes and keeping Europa's ocean liquid. Resonance isn't random. It's a stable pattern. Gravity carves into a system over time. The dance of these 3 moons is like a cosmic metronome ticking for billions of years, keeping worlds active purely through orbital rhythm. Moons can sculpt planetary rings with gravity. Saturn's magnificent rings aren't passive. They are shaped by tiny shepherd moons. These small bodies tug ring particles with gravity, creating gaps, sharp edges, and ripples. Pan, for instance, clears a crisp groove in Saturn's A ring, while Prometheus and Pandora herd particles in the F ring into a narrow strand. Without these moons, the rings would look very different. The interplay between moons and rings shows that even the smallest bodies can wield outsized influence, drawing order and beauty from chaos. Moons are keys to how planets form. Moons hold clues to planetary birth, some formed alongside their planets from a shared disk of material. Some were born of colossal impacts. Some were captured long afterward. Studying their compositions and orbits lets scientists reconstruct the history of planetary systems. Earth's moon, for example, exposes the violence of early collisions. Jupiter's moons showcase tidal heating. Saturn's moons interact with rings, while captured satellites around Neptune and Jupiter hint at ancient migrations. Together they tell the story of how planets grow, collide, and settle into the systems we see today. Moons aren't just companions. They're geological records of planet-making. Some moons may hide hydrothermal vents like those on Earth's seafloor. Deep beneath Europa's ice or within Enceladus's crust, the oceans may shelter hydrothermal vents, places where heat and minerals gush from the seafloor. On Earth, these dark oases teem with life that needs no sunlight, thriving on chemical energy. If similar vents exist on these moons, they could power extraterrestrial ecosystems. Enceladus's plumes already hint at salty, mineral-rich water rising from the depths. To imagine glowing vents in those hidden oceans is to imagine the possibility of life far from the sun, a parallel biology stirring in the darkness beneath alien ice. Life may arise on moons, not just planets. When we think of habitable worlds, we usually think of planets. But moons are just as promising. Europa, Enceladus, Titan, and Ganymede all offer conditions that could nurture life, liquid water, chemical energy, or organic molecules. Unlike dry Mars or harsh Venus, these moons might be lively below the surface, hidden from view. Life on a moon would expand our idea of where biology can exist, proving it doesn't need sunlight or Earth-like conditions. It only needs stability, water, and energy, things moons can provide. They remind us that the search for life isn't limited to planets. Moons can create mini magnetospheres of their own. Most moons lack shields, but Ganymede is the exception. It's the only moon that generates its own magnetic field, wrapping itself in a tiny magnetosphere. This bubble interacts with Jupiter's enormous field, producing auroras that dance over Ganymede's poles. Other moons, like Io, also induce magnetic responses in their parent planet as they move, revealing a deep connection between moons and magnetism. A magnetic shield would help protect a moon's surface or atmosphere from radiation. These magnetic signatures remind us that moons can behave like tiny planets with complex internal dynamics. Dust clouds from moons can form invisible rings. Some moons constantly shed dust, creating faint halos around their planets. For example, Jupiter's small moon, Amalthea, contributes particles to a thin ring around the planet. Even smaller moons and captured asteroids can be wrapped in debris clouds kicked up by impacts. These rings are usually invisible to the naked eye, but they appear in spacecraft images. They show that moons, though fragile and eroded, keep shaping their environment. Every strike, every grain of dust, leaves a fingerprint that spreads into space, linking moons and rings in subtle, hard-to-see ways. Some moons leak atmosphere into space. Even the thinnest atmospheres don't last forever. Moons like Io and Enceladus leak gas, creating faint clouds that trail behind them. Triton vents nitrogen to sustain a dim atmosphere, which gradually escapes into Neptune's orbit. Titan, despite its thick skies, also loses gas over time. These leaks contribute to a planet's magnetosphere rings or tenuous atmospheres. A moon's ability to hold or lose gas depends on gravity and temperature. For many moons, their pull is too weak. The gases escape constantly. Leaky moons show how fragile atmospheres are and how they continually reshape their surroundings. Moons have been found orbiting dwarf planets beyond Pluto. The Kuiper Belt beyond Neptune is filled with icy dwarf planets, and many of them have satellites. Pluto has 5 moons, including Charon. Haumea has 2, and Eris has at least 1. These distant systems are scaled-down versions of the planet-satellite relationship closer in proving that moons are common even at the frozen edge of the solar system. Their presence helps scientists measure the masses of their primaries and understand how collisions sculpted these far-off worlds. Each discovery expands the moon's extended family, reminding us the outer reaches aren't empty, but full of companions circling in the deep cold. Eris and Haumea may have additional hidden moons. The 2 large Kuiper Belt dwarf planets, Eris and Haumea, are not alone. Eris has a confirmed moon named Dysnomia, and Haumea has 2 known satellites, Hiaka and Namaka. But scientists suspect there may be more faint companions orbiting them too small or too dark for current observations. Their very existence suggests that even at the icy frontier, collisions and captures have built moon systems. These satellites help astronomers pin down true masses and illuminate origins. That such tiny, distant objects can host their own systems shows how common moons may be companions waiting in the dark. The number of moons may exceed planets by the thousands. While the solar system has only 8 major planets, it has over 200 confirmed moons, and likely many more still undiscovered. Gas giants like Jupiter and Saturn account for most, with dozens of satellites each, while even small distant dwarf planets host companions. Exoplanet systems are almost certainly crowded with moons too, though they're harder to detect. Across the Milky Way, the total could reach into the thousands. Moons may be the most common type of solid world, quietly outnumbering planets. Their abundance suggests that where there are planets, there are naturally moons, co-born, impact-born, or captured, gathering around them in large numbers. Some moons orbit so far away they're almost independent worlds. Not every moon hugs its planet. Some circles are at such great distances that they resemble captured bodies barely within the planet's gravitational reach. For example, several of Jupiter's irregular satellites orbit millions of miles out far beyond the main families of moons. Their orbits are long, tilted, and slow, making them feel like nearly standalone worlds. These remote moons are easily nudged out or even stolen by other planets during close passes. Their tenuous leash reveals the delicate balance of gravity, where a moon can be bound and nearly free at the same time. Others skim so close they practically brush their parent planets. At the opposite extreme, some moons orbit so near their planets that their existence feels precarious. Phobos is so close to Mars that it crosses the Martian sky in just a few hours. Io is tortured by tidal forces because it's locked in a tight orbit. Some of Saturn's inner moons nearly graze the edges of the rings, gliding just above the giant's cloud tops. These moons endure crushing gravitational forces, stretched and torn by proximity. That closeness can trigger eruptions, fracture surfaces, or even set off a slow process of disintegration. Saturn's moons sculpt the rings into exquisite patterns. Saturn's ring system is a living masterpiece, shaped in part by countless satellites. Tiny shepherd moons like Pan-Daphnis and Prometheus carve sharp edges and gaps, while larger moons use gravity to raise spiral waves in the rings. The result is a living canvas, where delicate ripples and crisp boundaries reveal the invisible handiwork of orbiting companions. Without these moons, Saturn's rings would be a hazy veil. With them, the rings become a refined, ever-changing artwork, one of the solar system's most beautiful interacting displays, chiseled by moons. Uranus's moons are named after Shakespearean characters. Unlike most satellites typically named from mythology, Uranus's moons draw from literature, mainly Shakespeare and Alexander Pope. Titania, Oberon, Miranda, Ariel, and Umbriel are just a few of Uranus's companions named from plays like A Midsummer Night's Dream and The Tempest. This tradition makes Uranus unique, lending its satellites a cultural thread tied to human storytelling, as if the planet carries a library of characters in orbit, reminding us that science and literature intertwine in shaping how we see the cosmos. Titan's orange haze may resemble Earth's primordial atmosphere. Titan, Saturn's largest moon, is cloaked in a thick orange haze of complex organic molecules. This smog hides the surface but may mirror conditions on early Earth. Billions of years ago, before life began, our atmosphere may also have been rich in similar compounds produced by sunlight-driven chemistry. Titan could thus be a frozen snapshot of our primeval past, hinting at the reaction chains that led to life and how life might arise elsewhere. Some moons may nurture prebiotic chemistry under ice or within thick atmospheres. On Titan, with methane lakes and organic haze, or on Europa and Enceladus with salty oceans and possible hydrothermal vents. Foundational reactions, amino acids, lipids, sugars, may be quietly assembling. On Earth, that chemistry blossomed into biology. On these moons, it might be underway now, or paused just shy of the final step. These worlds remind us that life isn't inevitable, but its seeds may be scattered throughout the universe. Moons could serve as refueling outposts for future space settlements. As humanity looks outward, satellites become natural stepping stones, our moon with water ice and eternally shadowed craters, Phobos and Deimos as way stations to Mars, Titan with a thick atmosphere that shields radiation, Ganymede with a magnetic field, another type of shield. Distant and challenging as they are, these worlds could host shelters, support outposts, even long-term colonies. Over time, their role in human expansion could rival continents for the explorers of old. The moon is Earth's first shield against impacts. It's not just a gentle nightlight, it's also a bodyguard that intercepts or deflects impactors. The moon's scarred face records countless collisions across billions of years. While it doesn't stop every threat, it reduces Earth's hit rate and stabilizes our axial tilt, damping extreme climate swings. In a very real sense, the moon is both shield and stabilizer, helping Earth remain a safe cradle for life. The moon once glowed red during ancient lunar eclipses. When Earth passes between the sun and the moon, our shadow falls across the lunar surface. Instead of disappearing, the moon turns red because Earth's atmosphere bends and filters sunlight, letting only warm tones through. If people once saw it as an omen, we now know it's the same mechanism that makes sunsets red during an eclipse. The moon reflects all Earth's sunrises and sunsets happening at once. Moons can be swallowed when planets migrate. Planetary systems aren't static. Giant planets often drift inward or outward over time, dragging their satellites along. Some moons survive. Others are lost to space or consumed. Triton was likely captured during such a migration. Many other satellites may have been digested long ago. The odd orbits of numerous irregular moons are footprints of these shifts, reminding us that systems are always rearranging. Some moons are born from collapsing rings. Around Saturn, seed moons can clump from the ring's icy particles. Under gravity, they grow at the ring's edge and may eventually break free as stable satellites. Just as Earth's moon may have formed from a colossal impact, Saturn's moons can be children of shimmering rings, delicate nurseries where gravity weaves lasting companions. Moons can bear the signatures of ancient comet impacts. With little atmosphere or weather to erase them, satellites preserve traces of every collision over eons. Some impacts came from comets' icy visitors carrying water and organic molecules. Striking Europa or Ganymede, they may have delivered key ingredients for chemistry, even seeding life. Earth has erased much of its oldest evidence. Moons remain time capsules keeping the receipts of cosmic deliveries. The moon rings like a bell after quakes. Apollo seismometers recorded that after moonquakes triggered by tidal stress or meteoroids, vibrations can persist for hours. The dry, rigid crust lets seismic waves resonate longer than in Earth's moist rock. For scientists, that ringing is a gift for probing the interior. For the rest of us, it adds a touch of eeriness to a world that hums when struck. Titan has rivers and lakes of liquid methane. It's the only world besides Earth with stable surface liquids but not water. Seas like Kraken Mare span hundreds of miles. Branching rivers cut valleys through an icy crust. Its hydrologic cycle mirrors Earth's methane evaporates, forms, clouds, falls. As rain and returns to lakes, a familiar pattern with entirely different ingredients. Enceladus's south pole is a realm of tiger stripes. There, the surface is fissured into long, parallel cracks, warmer than the surrounding ice, because tidal flexing heats the interior. From these fractures, jets of water and ice spray into space, supplying fine particles to Saturn's E-ring. The tiger stripes are direct windows into the hidden ocean, venting salty water and organics, precious clues to habitability. Europa's ocean holds more water than all of Earth's seas combined. Trapped beneath miles of ice and warmed by tidal heat, this vast sea makes Europa one of the most promising places to search for life. Its smooth, fracture-scarred surface hints at activity below. Observed plumes suggest water occasionally erupts into space, a great ocean world hidden just under an icy shell. Some moons are slowly spiraling into their parent planets. Phobos, for instance, is gradually being pulled inward toward Mars. In about 50 million years, it will crash down or disperse into a ring. Depending on size, orbit, and tidal forces, many satellites may face similar slow-motion death spirals. They remind us that orbits aren't eternal fate, can be a violent end in the embrace of the world they circle. Distant moons may be captives from the Kuiper Belt. Many irregular satellites around the giant planets have tilted, elongated, even retrograde orbits, clues they didn't form in place. Some may hail from the icy frontier beyond Neptune. Triton is the archetype, likely a former Kuiper Belt object captured by Neptune's gravity. Such moons carry fingerprints of far-off regions, cosmic migrants, proving that planets and moons trade members over billions of years. Not all moons are spherical worlds. Many are only a few kilometers across, more like captured asteroids than proper moons. Mars's Deimos is just about 12 kilometers wide. Jupiter and Saturn host dozens of tiny irregular satellites, some under a mile across. Without enough gravity to round themselves, they keep lumpy, potato-like shapes tumbling through space fossil leftovers from the building materials of planets. At the other extreme are moons as large as planets. Ganymede is bigger than Mercury. Titan has a thicker atmosphere than Earth. Callisto and Io dwarf our moon. If they orbited the Sun, we might classify them as planets. Instead, they live beside giants' companions large enough to have magnetic fields, atmospheres and geologies of their own, blurring the line between moon and planet. The moon holds the record for the coldest places in the solar system. In permanently shadowed craters near both lunar poles where sunlight never reaches probes, have recorded temperatures down to 410 degrees colder than Pluto's surface or the outer Kuiper belt. That brutal darkness locks water ice in place for billions of years, a potential future resource for spacefaring journeys. Some moons are bright enough that their reflected light can cast shadows. Enceladus, clad in fresh ice, reflects nearly all the sunlight it receives so bright it can throw shadows in space. That dazzling reflectivity doesn't just look beautiful, it reveals surface composition, hinting at fresh frost, clean ice, or dark, ancient rock. The moon has no wind, so astronauts' footprints remain. Boot prints, tire tracks, equipment, even flags, all are preserved potentially for millions of years, on a world without weather to erase them. Every mark is a frozen moment of history, a reminder that the moon is both a natural satellite and a long-term archive of human achievement. Some moons are so young they're still forming. Around Saturn, small seed satellites are coalescing at the ring's edge. As icy particles clump under gravity, they grow and may slip free to become stable moons. Moon formation is not just a story of the distant past. It's an ongoing, quiet process unfolding among shimmering rings today. We may be witnessing right now the birth of new companions around a giant planet, proof that the solar system is alive, still creating and changing. Moons can shatter and then reassemble after catastrophic impacts. A satellite's life is perilous collisions can pulverize it, yet gravity can sometimes pull the pieces back together into a new shape. Pan-Saturn's tiny ravioli moon may be the result of such a process. Many astronomers believe Earth's moon also formed from a colossal collision that tore apart a Mars-sized body. That violent origin shows moons aren't delicate ornaments, but resilient survivors capable of destruction and rebirth. Each one bears scars or structures that tell of cosmic violence and the power of gravity to rebuild. The origins of many moons remain an open mystery. Some satellites were born from collisions, some were captured, and some condensed from disks of material. But the birth stories of many others are still unclear. Triton's retrograde orbit suggests a capture, yet the details remain debated. Some irregular satellites may have originated from collisions between larger moons. Even Earth's moon, seemingly well explained, may be more complex than a single giant impact theory can fully tell. These mysteries keep scientists engaged, urging them to piece together clues from orbits, compositions, and impact scars. Exomoons are likely even stranger than what we know. Beyond the solar system, astronomers have begun to glimpse hints of moons orbiting exoplanets, though none have been confirmed with certainty. Theory suggests they could be more exotic than anything familiar, some circling gas giants very close to their stars warm, some as large as Earth with thick atmospheres and liquid oceans, perhaps even hosting life. Because exomoons are extremely hard to detect, they remain tantalizing enigmas, awaiting better telescopes to confirm them. The first definitive discovery would be revolutionary, proving that moons are not only common, but astonishingly diverse across the galaxy. Moons remind us that planets are rarely alone. Looking across the solar system and beyond, a pattern emerges. Planets almost always have companions. From Earth's solitary moon to Saturn's sprawling family. From tiny irregular satellites to planet-sized worlds like Titan moons are everywhere. They shape their parent planets, stabilize tilts, raise tides, feed rings, and sometimes harbor oceans of their own. Moons aren't an afterthought. They're a core part of planetary systems. They remind us that loneliness is rare in the universe. Most planets aren't solitary travelers, but members of relationships forever bound in gravity's embrace. And so our quiet journey among the moons comes to a close. We've gone from Earth's companion with its silent footprints and fiery red eclipses to Europa's icy oceans, Io's blazing volcanoes, and Enceladus's icy plumes. We've seen potato-shaped moons, planet-sized moons, and moons being born within Saturn's rings. Each world whispers that the universe is rich with companions, circling in an endless rhythm. As you drift toward sleep, let your thoughts revolve gently like moons around a planet. You don't need to hold on to the details, just keep the sense of vastness, silent worlds in orbit, and time stretching over billions of years. The night sky is full of stories, and the moons are among its most beautiful whispers. If this soft journey touched you, consider leaving like a subscribe or a gentle share. That small gesture helps others seeking peace find their way here, one drowsy traveler at a time. Now let the day close behind you. Let your breath fall into its own orbit, slow and calm. Imagine yourself floating weightless like a moon bathed in faint starlight, forever supported around a tender, invisible center. Sleep well, dream deep, and may your night be as peaceful as the stillest moon. See you in the next video from the Easy Sleep Science channel. Good night.